Okay, so let us try to understand how to draw acceleration diagram in case of 4-bar mechanism. So as shown over here, we are having this 4-bar mechanism. We know that this blue link is the input link, then this red link is the intermediate or coupler link, and this is the green link, that is the output link. Now suppose this OA is the crank, this AB is the intermediate link or coupler link, then this BC is the output link. Now we know that radial or centripetal acceleration of A with respect to O, where O is the fixed point, is directed towards the center, that is O. Then neither A is fixed nor B is fixed, so we can say that acceleration of either A with respect to B or B with respect to A. So let us assume that A is the center, so radial acceleration of B with respect to A is directed towards A. So this is assuming this A as the center, so radial or centripetal acceleration is directed towards A. So this is FRBA. Then tangential acceleration is always perpendicular to the link, but here its magnitude and direction is not known to us. Now in this particular output link, C is the fixed point, so radial acceleration will be directed towards the fixed point or center, that is C. So this is FRBC, and tangential will be perpendicular to this particular link. Now this O and C, they are the fixed point, so we'll mark them over here as the fixed points. We'll take this fixed point in a space as one point. Now start with the first vector, so FRAO, that is the radial acceleration of A with respect to O. So out of this A and O point is known, so from O point and this known magnitude and this known direction, draw this acceleration vector as shown over here. The second vector is radial acceleration of B with respect to A. Then out of this B and A point is known. So from A point, draw a vector to certain stable scale parallel to this particular vector and in the direction as shown over here. Now from this X point, draw a line parallel to this representing the tangential acceleration of B with respect to A. The next vector is radial acceleration of B with respect to C. So out of this B and C point is known. So from C point, draw a line parallel to this vector and in the direction as shown over here. Now draw a line parallel to this vector representing the tangential acceleration. So this tangential vector, that is nothing but FTBA, and this tangential vector, that is nothing but FTBC. Wherever they intersect, that is the common point of intersection, that's nothing but B. So this tangential acceleration of B with respect to A and this tangential acceleration of B with respect to C, they are having B point common in them. So this point of intersection is nothing but point B. Now join this AB representing the resultant acceleration of link AB. Similarly, join this BC representing the resultant acceleration for this particular link BC. So our first vector, it is the radial acceleration of A with respect to O. So arrow must be towards A, whose acceleration we are finding out. This is radial acceleration of B with respect to A. So arrow must be going towards the B. Then this is the tangential acceleration of B with respect to A. This is the radial acceleration of B with respect to C. And this is the tangential acceleration of B with respect to C, that is represented by this particular vector. And this is the resultant acceleration of B with respect to C. Now arrows must be towards B. So here this arrow will be towards B, and here also the arrow will be towards B, whose acceleration we are finding out. Similarly, in this particular case also, we can have the arrow towards B. So this we can draw the arrow over here. So, and here also we can have the arrow towards B. So this is resultant acceleration of B with respect to C, and this is resultant acceleration of B with respect to A. So in this way, we can draw the acceleration diagram in case of the 4-bar mechanism.